start with a question. Where do advertisers spend more money? Who knows? Online or television? Online. Sure? So yeah, 2017, just 2017 was the first year digital ad spending finally beat TV. That's just 2 years ago, just now basically. At 2012, Google already had more than 1 billion searches every day. At 2012, Facebook had 1 billion active users. But only now, ad spending in digital beats TV. Who knows this guy?
Yes.
So this was Steve Ballmer's reaction. Steve Ballmer, he was the CEO of Microsoft at the time when the iPhone 1 was released. And this was his reaction. It's a second.
$500 fully subsidized?
He said, who would ever pay $500 for an iPhone? And what happens today? 10 years later, an iPhone costs $1,000. We don't have a Microsoft phone, or at least I don't know of a Microsoft phone, and we know how iPhone sales look. And this is actually just for 6 months ago. This is a BMW board member said that a self-driving car would never work. This is 6 months ago. What do you think would happen with self-driving cars?
They're already there.
Yeah, it's there, it's happening. So, you know, the world's changing constantly. Things are changing all the time. Coming to talk here, I searched for things that may be interesting around data and are changing now. And I actually stumbled upon two interesting incidents. So first of all, this is Microsoft 365. It is down again. And this is another thing I identified. This is Tinder. It was down again. And this happens. We run, all of us, we run operations which are heavy, data heavy. They are network heavy. They consume a lot of things, and everything happens all the time. It's very, very hard to see it all, and things tend to break every so often. And I'm sure as data people, you know, we all appreciate that. Doing ETLs or whatever, making analytics. You know that 4 out of 5 firms experience network downtime, and 3 out of 4 IT errors reported by end users. Just by end users, they recognize most of the errors, that's not good. And a third of the outages are caused by human operations. It's very, very hard for us to see everything. It doesn't matter how many dashboards we have or how many analysts that we have. There's so much data out there, we just can't really see it all. How many things do you measure in your day-to-day, in the operations that you're in charge of? So you can, if you wish to respond to it, you can. Those are some things I thought that you may monitor. Maybe response time, as in the previous example. Maybe revenues. You may monitor conversion rates. You may monitor application errors. You may monitor number of leads. There's a lot of things that we want to see all the time. And it's not only that, we want to see those things by so many dimensions. I want to see leads per country and per city and for different device type. I want to see conversion rates for different product types. That's so much. Think of how many products and countries. I'm sure this is your day-to-day, so you know that. This is just too much to grasp. And well, can you? We can't see all of the data. This is from some of our customers. How much of your business, maybe you can think, how much of your business is covered by KPI? How much of your business is visible to you? Do you see 100% of your business? Is it 50? Is it a percent of your business? Do you have any idea from the operations that you run?
Less than 50, I would say.
Less than 50? Any? That's a reasonable ballpark? So what we see from the research that we've run with most of our customers is that dashboards give us visibility for about 3% in average. That's it. Some customers have static thresholds and they get better visibility, better understanding of what happens, but it's really, really, really hard to see. Think of, again, the number of users from a specific country, from a specific device, from a specific source. Usually we will not get down to so many levels. We look at that at a more higher level to see what we want to see. And only if things changes on the main countries that we operate, only then we see it. Only if things change in the main browsers we cater to, only then we see it. If things change for Firefox in Belgium, not sure we'll notice that, or probably we don't look at that. And what happens if we miss anything? What's the cost of missing something? It's very heavy on the business. It can affect customer satisfaction, of course. We have a case now with Walmart where they promoted griller, and they sold it at the price, the list price on the website was $4 instead of $400. And then a few thousand customers bought this griller for $4. And Walmart didn't want to apply that. So they said, hey, we're very sorry, we'll give you a coupon for $40 for Walmart, you can buy whatever you want, but we can't really ship that griller for $4. Customers were not that happy, and Walmart was not that happy as well because it's expensive. It affects brand value. It may affect engineering because they get a lot of alerts and they get bombarded with issues and everything is urgent and they can't really focus on building forward. And of course, it may have effect on direct revenue. And so, as the world changes, analytics also change. And today we have AI and machine learning, and there are things where, there are places where machines are much better than human. And we expect monitoring to be done differently. We expect it to be comprehensive. We need to see all of the data from all of the silos, be data agnostic, see everything, monitor everything, all the time, in real time, and it should happen autonomously. You shouldn't work for that to happen. A machine can see all of the metrics and do it for you. The learning should be adaptive. We know today that people used to tune alerts all of the time to see that the thresholds meet the needs. It shouldn't be done. It doesn't really make sense that if something is too noisy, we'll change the threshold. It's not the right way to go about it. And once monitoring really, once something happens, the alert, whatever we get, it should be spot on. We should get a root cause guidance, not a flood of anomalies all over, or a flood of alerts. It should be accurate and it should be actionable. In the talks earlier, it also mentioned how data must really be actionable. People must be able to do something with it. Those are some companies today that are already running autonomous analytics. I won't go into them, but we can talk about it later if you wish so. And this is what they say. They said that they use a smarter and scalable way to automatically monitor all of the key performance indicators and detect anomalies in the data. And this is what I preach for. This is what I think. I think we should, as data teams, we should give machines more power with regards to monitoring, and we ourselves should be more creative. We should more work in other organizations to make things happen. But we shouldn't really monitor data. We shouldn't really look at dashboards as much as we do. Not us and not our business users. When you do that, this is what happens. So again, this is real data from one of our customers, and they ingest 36 billion events every day. It's a gaming company. Think about that. It's a lot of engagement with the game. So people are engaging a lot. Every engagement is an event, and then you want to monitor that by different, everything by different dimensions. Out of those events, still millions are of business relevance. When you aggregate the data, you still have millions of events. You can't go over that. We had I'm sorry, I don't remember the name, but in one of the talks in the main hall was about was WikiLeaks? There was the journalist, sorry, Panama. So think how long, he actually mentioned how long would it take to scan over there. He talked about 26 years. We need to do it in real time, all of the time for all of the data. So no human can do it. So when running anomaly detection on that, we only have 45 different anomalies, but still 45 anomalies every day is too much. Only 2 of them really generate, 2.7 really generate alerts, and only 1 high severity alert occurred, and this is their day-to-day standard. So they ingest into machine learning systems 36 billion events every day. only to get 1.2 alert on what's really important. And this is, I think, this is how things should work. Let's play a game. Play. Next slide is a game. You should detect anomaly with your own eyes, okay? Let's see if you can. The first one that finds the anomaly, please raise his or her hand. Good. Want to express way?
No, I wasn't.
In the fourth row from the bottom,
Yeah.
and in the middle right under the A,
Good.
that should be red.
Beautiful. Way to go. So that's basically that's one of the things that we do when we look at dashboard. Every row has different patterns. Some of the patterns are really standards with no anomaly, but just as, what's your name, sorry?
Nickel.
Nicole. So Nicole just identified this specific row where there's a deviation from the pattern. And what we actually did, Nicole, for me it took longer, but Nicole identified the patterns and identified the deviation. And how long do you think it would take for a computer to do that? It's a split second, right? That's like this. And it's insane to think that we ask our business users or ourselves to do that. We look at dashboards all the time, and we compare week over week, or month over month, or whatever, to find those anomalies. That's not an efficient way to do that. The way to do it is like this. So what happens with anomaly detection is that data is ingested, a metric is ingested. This is real data, so it can be a number of users from a specific device, okay? In a country, whatever. And this is the data. And what we expect the machine to do is to build a baseline around this data, okay? And the baseline is the expected behavior range. And what happens is that when the metric just starts coming in, the baseline is quite wide. But within time, as machines are smart today, we learn that there's a daily seasonality. So it can be like morning hours are stronger than evening hours. And after 4 weeks pass, you can hardly see the baseline, because the baseline already also learned the weekly seasonality, so we know that weekends are not as strong as weekdays. And here we can really nearly see the baseline. And this is what should do. This is how it should, in my mind, this is how it should work. And together with building this baseline, in real time, everything should be analyzed. So something should scan all of that. And if something deviates from the norm, we should detect it as an anomaly. And if an anomaly happens, then there's another engine that should run and decide whether or not this anomaly is important enough to surface to a business user or not. Does that make sense? So another thing is, when an anomaly happens, we don't want to be flooded with too many anomalies, and we want to get full story. So just telling me that, hey, there's a drop in users in Firefox in, Belgium, it's not enough, because what can I do with that? It's important information, but what is the reason? What is the root cause for that? So, again, we can go the next mile. The next mile is what we call the 4 Ws technology. And this is what happened, where did it happen? You can make all of that together, create all of those together, then you have a real comprehensive story to tell. And in this case, there's a drop in purchase completed. And we see a drop in a lot of different countries. But countries isn't the common denominator, it's not the common dimension. The common dimension in this case is all are coming from Android, and all from unknown source. So traffic source is unknown or null or whatever. And also, there's another anomaly that happened in the same time, and we correlated both together, so we can see that there's a spike in this example, 400 error. So we understand there's something that is not responsive that correlates well with that. And by the way, a new version was released. So a full story like this can give us, or the business user, it depends on how the organization is structured, what they need in order to really go out there and solve the problem in hand. Can any of you share like how does something like this work in your organization? Do you have a really good example of operation like this that works? Okay. So it's important. AI today, it's very hard to apply AI to business cases at this point. It's not as clear. So there are not too many companies that apply AI in a business form that really work. And it's interesting to see the anomaly detection, which again is very important in big data. It's still in many cases not well built. If you have any questions, that's a very good time for that. If not, then sorry. Then I have a question. Can you share whether or not you suffer from incidents in your business today, and such things, incidents or issues that you are not aware of, and as I showed in the previous example, you get from the support team or from end users? Is this something that happens today?
Yeah, we get lots of various incidents, and we try to put in monitor in place. But you said it's the old style where you're looking at ratios and you expect X amount of records on a daily basis, and it's within 10%. It's okay. You've gone out. It's 30. So yeah, it's good to see how other companies are doing these things to try and be a bit more proactive on it. Right now we are 100% reactive.
Exactly. The proactive and reactive is exactly the kind of language that we talk, and it turns, again, analysts, I remember when I was an analyst, then a few times the CEO and VP engineering were like on my back, something happened, please understand what it is, and then you have to run queries really fast. That's not a nice situation to be in. And this turns the data, the analyst team, to be a proactive team, where you basically go on the offense. You say, hey engineering, there's an issue, we want you to know about it, instead of me having to really understand what happened. So in short, this is what I want to leave you with. Autonomous analytics makes business nice because it's faster, it's cheaper, and it's better. That's it. Thank you for your attention.